Hello, my name is Callie Wilson, and this is my Physics 2212 Lab 3 circuits. For my introduction, in this lab, real circuits will be created using equipment provided so that the measurements can be made and compared. The purpose of this lab is to measure values of current, voltage, and resistance via the effects that resistors and capacitors have in circuits. This lab will showcase the principles of the loop rule, node rule, and Ohm's law. The system is the circuit. The surroundings is literally everything else. The experimental model is the created circuits. There is no computational model, and the node and loop rule were proven true, as well as the usage of Ohm's law, which is some of the results from my experiment. As you can see right over here is Ohm's law, loop rule, and node rule as a visual diagram. And then as for their actual definitions, Ohm's law, the voltage is the voltage across a conductor is proportional to the current between 2 points. Loop rule, energy cannot enter or leave a closed circuit, so the sum of the differences in voltage around the circuit is zero. And the sum of currents entering a node equals the sum of currents exiting the node. As for my experiment, you can see a picture of what we made our circuit there. And a real circuit was created for each part of the experiment following the models shown to the right. Well, I guess in this case, to the left. The first circuit created has two resistors and ammeters. And the RC circuit created has a capacitor and a resistor. The batteries were put into a series, causing the voltage to add together. The resistors were put in series as well, so that their interaction with the total voltage could be analyzed. The charging and discharging of a capacitor with time were analyzed with the normal circuit and the RC circuit. Here's my calculations. As you can see, my steps throughout this process of just recording the data and milliamps I got and what it would become. And then as you can see here, me getting like battery, just testing out like all the volts, and then me getting the current. And then me answering the questions that we find in the lab doc that we did and creating this graph, filling it out with the data I got, and then also completing the stuff for the RC circuits about charging and discharging. Some errors and assumptions made. Some assumptions, resistance within wires is negligible since it is not a significant number, and the resistance in the ammeter is negligible as well. Errors in measurement and timing in the experiment, and there is likely a deviation in the resistance in the ammeter and wires from theoretical values. Some similarities and differences. The current was the same throughout the circuit in both models, as well as the voltage prediction and calculation. The loop rule was satisfied in both, and the observed and prediction models. The differences, there was some deviation between the beforehand calculations using backward formulas compared to the actual experimental model as a result of human error, of course, and the internal resistance in the battery and wires. To answer the discussion question, what if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? The model would predict that the capacitor charging to full charge would be very rapid. The prediction is not necessarily realistic. However, as resistance within the wire and other internal resistance would likely cause deviation from the prediction in the model. And that's it. Thank you. The end.